Hello, and welcome to the Side One YouTube channel. My name is Ray, and in this video, Spot Micro Part 26, we're going to have a look at an update of where we're at with the software so far. So I found a few little bugs with the leveling of the robot. As a result of that, I've modified the code and worked out the process for actually calibrating your inertial measurement unit. Now, when you mount your inertial measurement unit in the robot, and in my case it's hidden right down here in the back, it might not necessarily be flat to the robot. It might be close, but not fully flat. So the way I calibrated mine was to set the robot up on the stand that I've made, and then using the inclinometer or the angle meter mounted on the robot, adjust the level of the stand by putting packers under the feet until I got a zero reading in this axis, so the y-axis, as well as the x-axis. Once I was happy that the robot was level, I went into the Python, and I've got it, when you start it up, it'll actually create this start.py, too far, and you'll see the legs.set roll offset and legs.set pitch offset. I set both of those to 0.00. I then run the command print legs, and it gives you a fairly lengthy list of information, but more the one we're looking for is this pitch and roll. Now, the value that we want to put into that, or the configuration, is the value in radians. So up here we have got the pitch, and over here the roll in radians, and so we can execute that into the set of the pitch and the roll, and that'll calibrate our offset. For that, you may have to go into your program, the actual start program, and modify it to suit your robot. And I have got the start file, so I'll just bring that up so you can see it. So that number you'll then copy into there and there for the roll and the pitch, and that will calibrate the IMU for your robot. Once that's done and your robot's level, print of the status will bring it back to showing pretty close to zero. So once we've done that, we've got the robot's got an idea of which way is down, and to a fairly high level of accuracy as well. Okay, so I've got this robot in a rest position at the moment, which means it can't correct its level, not when the servos are all tightly packed up as far as it can go. And I've created here a couple of little short Pi files, status being one to print the legs because I'm doing that on a regular basis. I've got one for rest. Now, with the rest program, I've added in a number of steps so that it doesn't just drop like a rock on the desk or on the floor. So it's going to try and get to the rest position using 10 steps, and it's going to put a delay to allow the servos to get to those positions of 0.03 seconds. Those servos are very quick. Once I've got it in a rest position and known position, I'm happy to try and stand. And one of the issues I was having fairly early in the piece was the robot rolling onto its back. And the solution was to have the robot go forward prior to actually moving up. So I've broken it down into two functions. So let's demonstrate that. And now if I get a status, we can see the The robot's got a little bit of a lean on it, mostly in the roll axis in this case, around about 4.5 degrees of roll and 0.1 degree of pitch. So it's sitting pretty level, it's not too bad. We're aiming for a roll on a pitch of 0. And we have got, this is my program or programmed error correction that I have in the robot at the moment. So you can see I've got 4.5 degrees of error correction in this robot. All right, we've also got the robot plane reference position and the inertial center of mass reference. And you can see here that because there's a roll present on the robot, it thinks that the center of the robot's about 15.5 millimeters, nearly 15.6 millimeters offset from the center of the robot. So one of the things I obviously want to try and get it to do is to level itself. So there is a feature in there called Level Robot, and this is where I'm up to with my debugging at the moment. So I'll show you the issue I have with it at the moment. So when I did this on the floor and it was pitching up slightly, it fell over. Now this is an error in as much as these legs are literally was about 100 I would say 120, 130 mil, way too far forward, and it's trying to go even further forward again. So I have a fairly serious error only on the back legs. So that's the next area to concentrate with the inverse kinematics. All of the programs are available on the GitHub, so you can download them, see where I'm at any given time. Have a look if you see any features in there you might add to it and suggest them, and we can probably include those as well. Well, that'll do for this short video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have a Patreon account, and you can join my patrons, VIP Go Lucky, and my builder patrons, MRL 45 and Whitewalk. If you've got any questions or suggestions, I do have a Discord server, and you can join the community in Discord in helping to build these robots and make them better. I do try and answer those questions daily whenever I get them asked. You can also leave comments in the description below, and we'll see you in the next video.